We're still going to call today's homework 212, but we are definitely not going to finish that lesson today. So you do not have to finish that homework tonight. Likely, 212 will get pushed into Wednesday, and we'll essentially we'll shift everything down today. I don't care if you change what your plan book says or not. All I really care about is that you don't freak out and say, I'm going way too fast, because how you feel, this is one of those weird things that as you get used to Phoenix, how you feel is more important than my plan. Right? What I have planned doesn't matter if we can't keep up. Right? It's like if I put my foot on the gas pedal and people aren't in the car yet. Right? Does it do any good to drive forward if people aren't in the car? No! We got to get you guys in the car and then go forward together. So we're going to make sure that we feel comfortable with the stuff we did yesterday. Then we're going to finish up 211. Then we'll start 212. So yesterday we were reviewing long division. And did we get to this point where we actually wrote down this fraction? I think we did, but it was right at the end of class. So check your notes. Do you have this fraction written down? If not, this is where we're going to start. So pull out yesterday's notes. If you don't have yesterday's notes, get out a fresh sheet of paper, but you'd really rather continue yesterday's notes. It'd be way better for you. That's fine. You can copy notes from somebody or you can come get them from me. Did you happen to have a chance to watch the video? So you might want to do that at some point. So guys, we yesterday had gotten to... Oh, and there's no video from 3B. CX, the only video is from 1A, but it's the same stuff. We got to this point where we were talking about how we dropped down the extra zero, and the note that you maybe have written, hopefully maybe, is that dropping a zero, or an extra zero, puts a zero in our answer. So we're going to do more long division today to remind us of what things drop automatically. But guys, this zero, I might come up to the board. Ooh, almost tipped over. Guys, this zero is extra because we needed to turn my 20 into 200. Right? So because we dropped an extra zero down, we put an extra zero up here. Now, I'll be straight up with you. I hate long division. I don't use the word hate for very many things, and I hate long division. Like, I don't think there's any foods I hate. I don't think there's any people I hate. Maybe like Hitler. But like, hate is a heavy word, right? Like, I hate long division. So what's better is learning some strategies that we don't need to long divide. So the first thing I want you to write down in helping us try to avoid needing to do the long division, guys, if we would have recognized that this could turn into 99 by doing times 3, and this turns into whatever it turns into by doing times 3, the number, and I need you to write this down because it's gonna, we're gonna keep doing this. The amount of 9s in the denominator. Tell us how many numbers to repeat. 2 9s in the denominator. We repeat 2 digits. Repeating bar goes above 2. Like not the number 2, but 2 digits. So whatever the 2 digits on top of 99 are, they repeat. Weird thing about sometimes I gotta walk around before people will actually write things down. Alright, we need to look at 211, but we're gonna do that in a second. We're gonna look at 211, so if you haven't gotten it out, you could. So if I give you the fraction 42 over 99, talk with your group about what you think that turns into decimal-wise. Means there's an open seat over there at CX's group. I don't know why those got so weird, but there's an open seat over at the high tables. 0, of course, right after I shut the door.
Yep.
But better late than never.
Yeah.
So 0, the main thing you missed so far, the main thing you missed so far, 0, is us talking about the number of 9s in the denominator tell us how many digits to repeat. So, I know you've all been holding your breath all day long, waiting to come to my class and have random cards happen.
No.
It's okay. You can lie to your classmates, but I know you're so excited. Vera, what do you think this turns into as a decimal?
Oh, no.
Oh, yes.
42. 42.
Yeah, and I could just save myself time and just say 0.42 with a repeating bar on it, because 2 9s in the bottom tell me to repeat 2 digits. Now we're going to make it a little bit harder. Why? Because I want you to be ready for difficult things in life. Wait a minute. 2 9s on bottom tell us to repeat 2 digits, but there's only 1 digit on top. Talk with your team. Talk with your team. What do you repeat? I don't like that you're talking backwards, so make sure you can see where you guys might need to turn the shiny bit. I meant to move these tables and I forgot. Because they're supposed to be like kind of angled, so just make sure that you can see. We're slowing down if I need to. Yeah, y'all are smarter than me. Because y'all got it way faster than I think I would have. 7 really has a 0 in front of it, or as many zeros as we want. So this would become 0.0707 repeating. In case that was at all tricky for you, talk with your group. What does this become? What does this become?
007.
007!
Yeah.
Because there are really 2 zeros. If we need to repeat 3 numbers, we have to put 2 zeros in front of it and say 0.007, which any chance to play the James Bond theme song, might as well take it. How am I your teacher?
Yes.
A lack in stringent college systems and admissions.
Okay.
They just let anyone in there. You survive 4 years, they let you become a teacher.
Okay.
Yeah, just if you pass 3rd grade, they let you in.
So let's go look at 211 because we haven't done that yet. So you had 211 out, or you at least should have. We're not going to check the whole thing today because I know some of us need extra time. Guys, number 8 was just phrased kind of weird. If I buy a pizza and I tell you that every slice of it is a 1/10, how many of those slices do I need to make the entire pizza? 10! Because if each of them is a 1/10, I need 10. Now, for some reason, this pizza place is kind of weird, and instead of serving pizza in any normal amount of size, they cut their pizza into 100 slices. Kind of like Donato's, honestly. I feel like they're a little excessive with all the slices. How many 1/100ths do we need? 100 hundredths. So guys, all that number 8 is trying to tell you is to make a whole, you just need a number over itself to make the entire whole. To make a whole object, you need the same numerator and denominator. There were a couple of these that I specifically want to go over. So look at 2-11. Need to get my homework back out, but where did that binder go? 2-11 says Nicole has a machine that's going to generate random numbers between 1 and 50. So how many options are there for numbers between 1 and 50? 50. So the first thing we would want to identify is, first off, Mr. Hudson has typos all over, because I actually bolded the M, don't know why. But 1 through 50 tells us the denominator's gonna be 50. So guys, this tells us straight up, every one of our fractions can start with a denominator of 50. For a multiple of 10, guys, anytime we're dealing with multiples, you can get out your multiplication table. Now, multiple of 10 is not too tricky, but multiple of 4 might be. So multiples of 10, 10, 20, 30, 40, 50. How many of them are there? There are 5 out of the 50, but of course that could reduce. Ooh, 1 what? 1 what? Guys, when I... There we go. When I do that, it's not because I'm hard of hearing. I'm not that old yet. It's because I'm wanting you to think about the math again. It would be 1/10 if we reduce it down. A number that is not 100. How many numbers between 1 through 50 are not 100? All of them! So either 50 over 50, or you could just put 1. This is the toughest problem here, at least based off what people came to ask me. Not a multiple of 4. Guys, not normally tells me I'm going to have to do a subtraction. So for multiple of 4, guys, grab your multiplication table and just say, how many numbers do I have that are multiples of 4 before I get to 50? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we know that we had 50 numbers to start with. Guys, if your homework isn't done and you aren't doing this with me, you're just crazy. I'm doing your homework for you. Why wouldn't you take advantage of this? 50 minus 12, because there were 12 multiples of 4, leaving 38 numbers that were not multiples of 4. And one-digit numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 of them out of 50. Did we say you had to reduce these fractions? Absolutely not. Could have left everything over 50. I would have been fine with that. 0. It's alright, so did I. What? 12.5. No, but 52 is not in our set. But it's not in our set. It's not a possible result. It's like if I tell you I have a green fish, a blue fish, and a red fish, and you say, what's the probability of getting a brown fish? Like, well, if there aren't any brown fish, we can't get it, right? So if we list out all of the things that can happen here, it starts at 1 and goes up to 50, so 52 cannot happen. Does that make sense? That's why there were only 12 multiples. There was another one that I wanted to talk about. Look at 16 on the back. They tell us that in this diamond, there is a special pattern or a special thing happening. And the more I talked to people, they said, yeah, it's the numbers on the sides relate to the top and then they relate to the bottom. Can anyone talk to me about like what is going on here or what you figured out? And it's okay if your homework's not done, but it's not okay if you never plan to ask questions, right? So I had people come and ask questions yesterday, which told me what we need to talk about and what kids are struggling on.
So the similarity between this is 10 and 7. 5 multiplied 7 is 2, but 5 plus 2 gets us to 7.
Oh, I would make yourself a note on your paper. The bottom is the sum. The top, a lot of people forget this word, product is the answer to multiplication. What you produce, your product, is the answer to multiplication. And then as a reminder of how to turn mixed numbers into single fractions, a single fraction most normally means improper. So to turn that into an improper, we're doing 2 times 15, then we add the 4. Because it's like if I have pizzas cut into 15 slices, then 2 of those whole pizzas would be 30 slices. An extra 4 slices, I got 34 over 15. All right, that's all of the homework that we're going over today. We will go over the rest of 211 tomorrow, unless there are questions. 0? D? For which one? For this? So, no, not today. But what I'm going to tell you is what you need to think of is what 2 numbers can add up to make 11. So I could start making a list, right? Like 10 and 1, 9 and 2, 8 and 3. Right, I can keep going because what numbers add to make 11? And then figure out which of those would multiply to make 28. So we got to think through the options, right? So play with your options. And we're allowed to use decimals too, but right now I doubt we'll really be using decimals. So you're allowed to, but I don't think we need to quite yet. But we'll go over these answers tomorrow. No worries. We'll go over the rest of it tomorrow. All right, go ahead and... Actually, you can keep this out if you want. We might have time at the end of class to keep working on this. So keep it out. Just get your notes paper back out. We're going to do 1 divided by 7. But we're going to use it as a nice reminder of how long division works. So guys, if you come with me up here, and actually I'll do this whole first step again. Give me a second to erase. I mean, you guys can write as much as you want. But this is number 6. We're still on yesterday's lesson, actually. We're still on yesterday's lesson, actually. 1,000,000. No, probably about 7. I just do a lot because, like my mom said, I'm a special little boy. But you don't really need that many. Any proper fraction. Proper, meaning the number on top is smaller, you know will be a number less than 1. So, guys, some of us got in the habit of just, I know this 0 goes here. Go ahead, that's perfect. If you don't remember that, we do 0 times 7, subtract away 0, the 1 comes down, and the 0 drops down automatically. This is what I was trying to remind us about yesterday. As soon as I do my subtraction, a 0 drops automatically. Then we're saying how many 7s fit into 10, which is how many? 1. So we say 1. That subtracts 7 away. So my 1 times 7 is how I have this 7 down here. But now I get 3. But a 0 drops down automatically. And we get 30. Continue this with your group. Continue this with your group. See if you can figure out what's going on here. How many 7s fit? 30. I have papers for you. I have papers for like everyone, I think. I have papers for you for sure. No CX because he was not here. Every time we like being negative, right? Gravity
Are you
works.
for real making again?
I'm giving you the opportunity to practice math and learn and master skills. So yes, I am giving you this opportunity. Again, you are welcome. I know you're so excited about it. But now after this, you might remember this. Like forever. Well, it's all about the process. This, I can't remember if this had anything to do with this morning or what we were talking about, but okay, so there's my little note for that. Braden. Okay. Chloe's not here.
Where did you get that?
He told me to turn it to let you know if I turn it something late.
If you like, if the grade needs changed like now, all of that should be up to date.
This is just a day late.
So you're turning in closure right now. This is not my grade binder. Sorry, right now is kind of a rough time to try to make me multitask, but give me just a second, and I might be able to. So I also need 126, 127, and 128 from you. The only thing you turned in was 125. At least that's the only thing I have checked off. So if I forgot to check things off, let me know, but I have not seen your 26, 27, or 28.
If I don't have them in my binder, I'll probably turn them in.
Come around, I can't hear you.
If I don't have them in my binder, I'll probably turn them in.
Okay, well, you didn't because I've graded everything. I haven't seen it. So either they're on the chalkboard, no name, or dry erase board, no name, or they're in your binder or somewhere else. Okay, I've graded everything that has been turned in. Like, except for what's in the bin right now, I've graded everything. Okay, so come see me at Extensions if you want to chat about it. I wouldn't. I'd try to find your other papers. Turning that in won't do anything. You know what I mean? That's not everything that I need to see. Y'all ready for this? Sorry, NBA Jam. Yeah, my friend used to work for Apartments.com. This video is sponsored by Apartments.com. Please pay me. If Apartments.com would like to pay me, that'd be sweet. How many 7s fit into 30? 4. What does that get us? 28. When we subtract the 28, we get a 2, and we automatically drop down a 0. How many 7s fit into 20? 2. That gives us 14. We subtract that, we get 6. Drop a 0 automatically. How many 7s fit into 60? 8. That makes 56. Hey guys, even if you understand what you're doing, not all of us do, so you're being rude right now. We subtract the 56, we get 4. We drop a 0 automatically. How many 7s fit into 40? 5, which gives us 35. Woo! I'm going to run out of screen. Drop a 0 automatically, getting us 50. 7, because 7 times 7 is 49. Oh my gosh. Running out of screen. Like literally my camera can only zoom out so far. Why is that 10 highlighted? Raise your hand. Why is that 10 highlighted? How do we know? We already did this. Guys, the definition of repetition is something you already did. Right? So exactly, we already did this. This indicates that right here, guys, I need one of those soundboards where it's like, bow, 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 like the whatever sound that's like the horn thing. No. Yeah, the air horn things, whatever. We need one of those excitable sounds here. Yeah, I might get in trouble if I do that in school. So guys, now if we keep going.
Excuse this interruption, Phoenix. Could I please have Layla Graff to the office? Layla to the office, please. Thank you.
If we do a 1 and get a 7 and get a 3, we start the same thing we did all over again. So yes, we already did this. Vera, would you like to remind us what 2/7 was?
That just goes to, when did it go to 28, 57, 14?
Yeah, what's the next biggest number we could start with? So guys, you want to make a reminder because tonight's homework is all about converting fractions to decimals, and these are good to have written down to make your life easier. 2/7 starts at the next biggest decimal number, but still repeats the same digits in the same order. It just starts at the 2 instead. I'm going to show you all of these to remind you how they all relate. So you should write these down. And notice I didn't do all of them. I'm not trying to make you do all of them. We did this back in chapter 1. But I bet barely anyone remembers. Because we never tested on it or anything like that. So 14, 28, 57, it all repeats. We still have 14, 28, 57. We just started at a different number. We still have 14. We got to loop around for that one. 28, 57. Every time we move on to the next numerator, we move on to the next biggest number in the tenths place. Yeah, because it has to be bigger. And if we, unless you want to do the long division for these. You do want to do the long division? Oh, you don't want to do, you sure? So we could long divide these and find this out. Because what I'm trying to give you is a little bank of things that you can say, oh, that's in my notes. I don't need to divide that. I'm just going to go copy it. I'm trying to make your life easier. Seriously, I'm trying to make your life easier. That's why I gave you a multiplication table, everything else. So, sevenths create a cool relationship. All right. Please write this down because it's gonna be on your test. I'm not even gonna jokingly say hint, hint, cough, cough. I'm gonna test you on this. Last test, I realized about a third of us probably are mixing up numerator and denominator. The denominator is the bottom. It's the part that's on the down. Hey, there's my alarm, Mallory. So the denominator tells me how many pieces we need for an entire thing. So if we have more than that, we have more than the entire thing. If we have less than the denominator, we got less than the entire thing. So the number in the denominator tells us how many pieces we need for a whole. When we are converting fractions into decimals, what would we like the denominator to become? We talked about it yesterday. We wrote it in our notes yesterday. What's the first one? 100 is one of them. Guys, if we are converting into decimals, what we would like is a 10 in the denominator, or a 100 in the denominator, or a 1,000 in the denominator. This is in yesterday's notes. This is not new. So if you were here yesterday, you should have had this written down. And that's also why we do long division, is it breaks us up nicely into tenths, or hundredths, or like it breaks nicely. All right, so some vocab review that you don't have to write down. All right, make sure you're watching the clock. A mixed number just means number and fraction. It's mixed. It uses both. Number, fraction. Soapbox. If you guys don't know what it means to like get up on a soapbox, it means like you're going to complain about something that like not everyone complains about. Improper. Notice that here it's not even bold. It's like right here they say improper fraction. I don't like that name at all. Because improper makes it sound bad. Guys, 13/3 is better than what the decimal would be. Because 13/3, if I try to turn it into a decimal, is 4.3 repeating. And that's not even 100% accurate. It's very close. Because improper fractions are really good. So I want you to like, improper, it sounds bad, but they're really good. Improper fractions are really useful. But sometimes we're asked, turn your improper into a mixed, so we know how many total pizzas we have and then how much left over we have. So 13/3 as a mixed would be 4 1/3, but I still like that better than the decimal. A lot of times we like the fraction better than the decimal. It's more accurate. All right, we should probably at least look at 212 so we can say that we started it. Portions webs. What's up? Sweet. By the way, I'm going to start betting dozens of cookies. If you guys come to me and you say, I turned this in, I swear I turned this in. If I find it in your binder, you owe me a dozen cookies. No, I'm joking. You don't owe me anything. But I do like to bet and see like how confident you are. I did that with one of your classmates earlier, not in this class. And he jokingly said he's going to bring me a dozen cookies because he was arguing. I turned it in! And I said, what if I look in your binder and find it? And he was like, I turned it in! I was like, all right, would you bet a dozen cookies on it? And
If we win the bet, you guys
there's no way you're going to win the bet because I know what I've seen. I know what I've graded. And when I know I've graded everything, I know you didn't turn it in. You know what? Like, I don't bet on not sure things. Except for a bag of Kit Kats that some of you have heard, I lost that bet. Okay. A portion web. And guys, I'm going to tell you, somebody in the morning class was trying to copy their notes in their homework, and it's not the same. I'm telling you right now, it's not the same. Let me double check if I have this. Somebody looking at 212. Did I give you any examples from class in 212? No, sorry. We jump right into no. That's still 211. 212.
212 starts at 2.
Yeah, it says this is your practice work. So yeah, it jumps right in. All right, let's talk about this then. The portions web. Just give me your eyes up here real quick. You don't have to write this down. The portions web takes a portion of a whole, right? Portion means not the entire thing. Like 2/3. 2 out of 3. If we order a pizza, I'm going to eat 2 slices. You get the third one.
Sorry for the interruption. Could I please have Cooper Florence, Steffi Kipling, and Maddie Richner to the office? Cooper, Steffi, and Maddie. Thank you.
If you absolutely don't want to do the portions web, Ava, I can tell you're not paying attention. If you totally don't want to do the portions web, you can just write them all out. Okay, so the 4, not just 3, the 4 things I need for these sort of homework questions are the verbal, guys, this is what a lot of people forget about. Verbal, how do we say it? Like literally, not point, like we say the actual name. We don't say point, like ever, when we're saying it correctly. So we do not say this as 0.7. We say this as 7/10. However, if we relate it to hundredths, we could do a times 10 on top and bottom. You can. Sure, I mean, we'll come back to it tomorrow as well. It's part of your homework. I'm going to give you a couple minutes to work on homework here in a second. This is how we get to percent, right? By putting that 100 on bottom. So your verbal could also be 70 what? Hundredths. So there are more than one right answer here. But on portion web questions, because I want you to be ready for the mastery, I don't care if you draw a web. I don't care if you draw the triangle. I don't care if you write your words inside. What I care is that you know all 4 different ways to write a number. Verbal, fraction, decimal, percent. So now we got about 5 or 6 minutes left. What you cannot do is nothing. You can either work on 2.1.1 or 2.1.2 with your group. Turn it in and then I'll update grades this evening. If I had like time right now, I might update it right now, but I gotta walk around and check on people. No, I said it might. Tonight we're still leaving as saying 212. Here, I'll go back to that slide. Tonight we're still saying as 212. What might change, and probably will, now that we know we only covered. So what's gonna happen is this is gonna turn into 212. This is gonna turn into 221.
Oh, but we'll already have 212.
You already have it, don't you? Yeah, you already have it in your packet.
Yeah.
And then 221. Yeah, so essentially just this homework is going to span across 2 days. So you've got a day to catch up extra. Yeah, you've got like an extra bonus day.
Okay, that makes sense.
Yeah. Yes. Any other questions from last night you want to do together? Okay, fine. I guess I'll go back and do that one now.
Also, before you do that,
Very demanding. Before I do that,
I know that you need 1.2.5, but do you also want 1.2.7? The closure to 1.2.
here is what I need from you. All of these things. So 1, 2, 5, 6, 7, 8.
That's exactly what I have right here. Cool.
Yes. On 211. So I gotta look at you even though I can barely hear you. What do you want? Number 9B. Yeah, as soon as I do this one for 0, number 9B. Okay, it's in my head. All right, so by the way, still recording. So if you ever miss class, you might want to check the end of class videos for homework answers or beginnings of class videos. 0 requested this one again, so I'm just going to ask questions until y'all are satisfied. So if we're trying to sum to 11, we said 10 and 1, but if I multiply those, it gets 10. That doesn't work. So 9 and 2, but if I multiply those, that gets 18. We're getting closer. 8 and 3, but if I multiply those, 24. 7 and 4. Oh, I get 28. It's got to be 7 and 4. Because those add to my 11 and multiply to get to the 28. Does that make sense? So think through what other number adds and then then it kind of all comes together. So here, remember, this is multiplying. So what number would it need for multiplication? 6. Into 9B. So I'm going to do A first, because doing A first makes B make more sense. We said to convert these to decimals. Guys, if you have not done number 9, you should be doing it with me right now. It's tough, and I'm doing it for you. We said we want the denominators to be 10 or 100, or 1,000, or guys, any power of 10, right? 10 times 10, 10 times 100, 10. Like, we just keep multiplying by 10, or keep dividing by 10, however you want to think about it. 2/5 becomes a denominator of 10 pretty easily, right? We double it, right? Times 2, we get 4/10. That would give us 0.4 when we write it out. But 3/8, I'm going to write it up here. Can 8 multiply easily to make 10, and the second little part that matters, and not put a decimal number up here? No, can't happen. This cannot multiply to become 10 without a decimal going on top, and we can't work with a decimal in our fraction. That's called a complex fraction, and we don't know about those yet. Could 8 multiply by something to become 100 and avoid the decimal? No, I can try it. It's times 12.5. This would be times 12.5. And this would become 37.5, I think. But still, there's a decimal. Doesn't work.
Please have Charlotte Ogdenist to the office. Charlotte?
So, we keep going up. Can it become 1,000? Yes. That is times 125. So this becomes 375,000. Good thing I'm wearing a mask, right? And that is written using 3 decimal places. So 375,000 ends in the 3rd decimal spot. Robert.
If you want to simplify, or not simplify, when you have a 3/8, and if you need to put it into a bigger number in order for it to not be decimal.
Yeah.
Like for example, for this one, it's 12.5. In order to turn into it's 12.5, you gotta multiply by 12.5. But
Yeah.
Fraction,
You guys can pack up, by the way.
But you can just put, or you can just keep moving them back.
Keep shifting the decimal.
Yeah, it's multiply by 10.
Who what? Yeah. Yeah, I like it. Yeah, I wonder if that always works. You know what I mean? I wonder. I'm just curious. All right, get on out of here, guys. Have a wonderful day.